All right, how good is the census? Printed below is a story which can be used to demonstrate the effectiveness of a census. Assume that the letter capital G or lowercase g is a defective product caused by the gremlin, and that you are the inspector. Allow yourself about 3 minutes to count all the G's or capital or lowercase g's. Place your total at the bottom of the story. Now, I'd like you to, everybody hit pause and go ahead and do this on your own. Of course, you can just watch right now and watch me do it, but you won't get as much out of it. So please take a couple, 3 minutes, whatever it takes to read through the story slowly and identify all the G's. It's going to be harder than you think. Okay, hopefully you're back and you have done it on your own. Maybe you'll catch ones I miss as I go through it. Now, you can read the words or just look for letters. I'm going to read. While strolling, oh, there's a G right there. Through a glen. The glen, that's G right there. But then as I realized, after I did that, there was a G right here. Okay? But I didn't get that at first when I was reading, because it's that silent G. So maybe reading it is not the best strategy, because our sound might throw us off. I don't know. It may be different for different people. Reading it out loud, not sure. So giddy English girl tripped on a rather large, almost gigantic, ooh, there's two right there, frog. I'm not missing one. The girl staggered, so there's two of those, but regained her footing, ing, and was about to go on when the frog, I'm kind of looking for other G's that I missed as I move on, began, hard G, to speak and gesticulate, to gain the girl's attention. I had not always been a frog. Okay, right there. He croaked. Of course, if you don't want to watch me do this, you can go ahead and fast forward a little bit. The frogs, you can see I'm struggling with it myself. Green, hard G, coloring, seemed to glow. There's a G right there. Brightly, a hidden G in the middle. As he continued, I was once a gracious knight. A gentleman called Gallant, oh, we have some capital G's, those should be easier to find. George, lowercase, capital, Greenville, but was changed, that G in the middle, into this ghastly frog. You now see no G, by an ungodly, magical genie. The spell can only be broken. I just feel like I'm missing some G's. Only be broken if I gain, there you go, gain, a girl's good graces, and spend a night, there's a silent one, in her garden, hard G. The agog, two hard G's, girl was skeptical. Of course, she gazed, there's a G right there, at the frog's pleading eyes. Oh, I almost missed that G in pleading. I kind of went back. And soon her doubts gave way to her giddy nature, giggling. Three of them, right? Oh, no, four of them. See, it's easy to mess up. She decided to grant hard G, the frog's hard G wish, the frog's wish, and took him home straightway. Silent G there, putting him by her garden, gate, by her garden gate. That night, silent G right there, the girl, hard G, slept grandly, and sure enough, hidden one, when she awoke the following morning, there alongside her garden gate was the gracious knight. There's silent G in there. George, oh, almost missed that one, Grenville. Well, strangely enough, let's see, Easy one to miss there. For a long, long time, the girl's mother did not believe that story. It feels like I'm missing one. Mother did not believe that story. Doesn't look like I'm missing one. So let's count that up. How many circles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Doesn't help when the circles aren't lined up. 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Oh, I lost count. 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. Counting for more G's as I go. 60. Oh, look at this. I missed one when I was counting. 61. 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82. I wonder if I missed any other ones. So there's my total, 82. All right, so we have learned that the population is the entire group of individuals for which we seek information. A census attempts to contact every individual in the entire population. Okay? Every individual. That's the attempt. Sometimes the sampling process destroys an object, so you can't look at the entire population. Testing acid levels in an orange crop. Okay? There's cost, logistics, ethics, etc. also may preclude looking at the entire population. These are things that make a census hard, or difficult, or challenging. All right? Now, sampling and survey designs. How do you go about doing a survey? What different ways are there? Oh, this board's going to drive me crazy. Okay. Sampling involves studying part of the population to gain information on the whole. We've learned that sample is the part of the population we actually examine to gain information. Sampling design is the method used to select a specific sample from the population. So there's more than one way to do a sample. Simple random sample. This is the most basic type. SRS, the abbreviation, means every possible sample of the same size has the same chance of being collected. Okay? So if you randomly just, pick a number out of a hat, or pick a letter out of a hat, or put all the information up on a board and throw a dart at it, everything has the same chance of being picked. It's a simple random sample. Sampling without replacement. An individual can only be selected once in the sampling process. So think about it. Let's say you're playing Scrabble and you pick a letter out of the bag. If you don't put that letter in the bag, no one can pick that letter again. Now, there might be more than one letter in the bag of that type, but that letter can't be picked. It only had one chance. The sample includes n distinct individuals from the population, n being that number. With replacement, once selected, an individual is replaced back into the population and can be selected again. So I can put that letter back in the bag and pick it back out again. Okay, think about lining up for a picture. If you stand in the first spot, can you also stand in the second spot? Or the seventh spot? No, you can't replace yourself. Once you pick a spot, you can't be replaced. That's the difference between replacement and not replacement. Oh, board. Technology. I think that's the end of the page. Yep. Okay, other sampling techniques. Stratified. Strata means groups or layers. Okay? So if you divide the population into groups and select a random sample from each group. Okay? So if you divide up the senior class and put them all in different rooms, and then you randomly sample each room, that is stratified sample. Or if you go to an elementary school and all the third grade classrooms, and you randomly sample from each one, that's stratified sampling. Cluster. Divide the population into groups, kind of like strata, but we call them clusters, and select all of the members in one or more, but not all. So let's go back to the elementary school. Let's say there are 4 third grade classrooms. At first, that sounds like stratified because we're dividing up into groups. But instead of randomly sampling, them, we select all of the members in one of the classrooms, or 2 of the classrooms, or 3 of the classrooms, but not all 4. That's the difference between cluster and strata. It's set up the same way, divided into groups, but stratified is random sample in all of them, and cluster is all of the members in some of the groups. It can be a little confusing, I understand. Systematic. Choose a starting value at random, then choose every 3rd one, or 7th one, or 12th one. Okay, so if you listed all the people in senior class at Rockwood Summit, and you just randomly started at whatever name, whatever. You picked a random number, you threw a dart at it, whatever. But then from there, you pick every 3rd student, or every 7th student, or every 8th. That's systematic. There's a system to it, a method. Convenient sample. Sampling that's done that is easy or convenient. Usually does not tell you information that you can infer to the population. So people standing outside the library and just taking a survey, that's convenient sample, because it's just the people who are going to the library. That may not represent the entire community. Or convenient sample is going down to first lunch. That may or may not be representative of the entire school. Okay? So it's convenient. First lunch, I'm available. I want to ask people here randomly, but it may not represent. Okay? So, some examples. You're doing a study to determine the opinion of students at your school regarding stem cell research. You ask every 7th person who walks into the library. Wow. Again, the thing with stats is, it's not always right or wrong, or one answer. You ask every 7th person. This gives the answer of systematic. But when you say it walks into the library, that's a convenience sample. So I would actually, on a test, take either one. I would take, systematic, sorry. Systematic, I'm just going to abbreviate. Or convenience. Because it kind of is both. Now, I could see how you would argue that since you're supposed to randomly start somewhere and then take every 7th person, that the randomness is the people in the library, and therefore, since you're taking that as your starting point and then going every 7th, it would be systematic. But if you're just doing people in the library, that's a little bit different. Now, if you did it at the entrance of school and there's only one entrance, and you did every 7th person, that would definitely be systematic. But when you're talking about just people in the library, that's convenience. So I would go either way. You divide the student population with respect to majors and randomly select and question some students in each major. Okay, so you divide them into majors. That's a group. So now we know we're at stratified or cluster. Here's the important point. Are we asking every group, some people in every group, stratified, or only some majors, but everybody in those majors? Let's see. Randomly select. As soon as you see randomly select, probably going to be strata. Some students in each major. If it's some in all, it's stratified. So I'm not going to say strata, I'll just say stratified. You assign each student a number and generate random numbers. You then question each student whose number is randomly selected. That's simple random sampling. You split students into 5 groups. Oh, groups, stratified cluster, based on birth date. And choose all students in randomly selected groups. Well, you split them up into groups based on the birth date. Okay? So that's either strata, that's like 3rd graders. That's kind of based on birth date. So they're in groups, you know, stratified or cluster. But you're choosing all students in some of the groups. This one's cluster. Okay? And that's it. This activity we're going to do in class.